Okay, everybody, so we're going to talk about the product and quotient rule in this section. And in the product and quotient rule, one of the things that we're going to notice is that we get out of the realm of some of those simple rules. You recall that, for example, in the last section that we talked about, we had something called a sum and difference rule. And that was a really simple rule because when we took the derivative of the sum or difference of two functions, what we found was that the derivative was just the sum or difference of the two derivatives. Could the same be said for products? Well, no, in fact, it can't. What we have to do is we have to take a little bit of more of a complicated setup here. And here's the way this one works. We say that if we were to take the derivative of f of x times g of x, it would be the same thing as f of x times the derivative of g of x plus the derivative of f of x times g of x. In other words, what we're doing is we're taking the first function times the derivative of the second function and adding to that the derivative of the first function times the second function. Now I'm going to prove this in a separate video, but let's go through and illustrate how this rule is going to work. And here's our function h of x, and we're going to treat it as a product of two different functions. So our two different functions in this case, we're going to call f of x this first one. F of x is the same thing as 3x squared cubed plus 2x in this case, and g of x, that's going to be x squared minus 5. So what we're going to do is we're going to take advantage of this product rule right here and say that if we take the derivative with respect to x of h of x, we should expect to find the following. Our first function, 3x cubed plus 2x, is going to be multiplied by the derivative of our second function right there, which is our x squared minus 5. We're going to add to that the derivative of our first function, and I'm actually going to put x squared minus 5 first so I don't mix up which one's getting derived here, times the derivative of the quantity 3x cubed plus 2x. So now when we work this out, here's what's going to happen. This is going to look like 3x cubed plus 2x times the derivative of x squared minus 5, which is just 2x. And added to that, we're going to have our other function, x squared minus 5, times the derivative of our first function right here, which is 3x cubed. Well, that becomes 9x to the second. 3 times 3, subtract 1 from the exponent, plus 2. So you can see here we have f times the derivative of g plus, in this case, g times the derivative of f, but you get the idea. We can put it in that order just to make it simple on ourselves, and that's the way it would look. Now, of course, we can go through and simplify this, and for continuity's sake, I'm going to go ahead and do that by multiplying through with our terms. So I'm going to take 3x cubed times 2x. That's going to give me 6x to the fourth, plus 2x times 2x, so I've got 4x squared. And added to that, I'm going to multiply together 9x squared times x squared. Use my FOIL method. That becomes 9x to the fourth. We're going to have, let's see, x squared times 2 minus 45x squared. So 2x squared minus 45x squared is going to be minus 43x squared. Minus 5 times positive 2 is minus 10. So if we combine our like terms together to simplify this one more time, we would see 9 plus 6, that's 15x to the fourth, plus 4 minus 43, that's minus 39x squared, minus 10. Now, how do we know that this is what we're going to get? Well, let's, for comparison's sake, ask what would happen if we had started out just by multiplying the factors of h of x together right here. And so h of x, if we multiply these two together in our original function, we'll find to be, let's see, 3x cubed times x squared becomes 3x to the fifth. We're going to take 3x cubed times negative 5, that's minus 15x to the third. Take our two middle terms, plus 2x times x squared, so that's plus 2x cubed. Then take our last terms, 2x times negative 5, that's minus 10x. Combining the like terms together, it turns out that h of x becomes 3x to the fifth minus 13x cubed minus 10x. And so if we take our derivative of this expression, here's what we see. H prime of x is 3 times the derivative of 5x to the fifth, which is 5x to the fourth, so that's 15x to the fourth, minus 13 times the derivative of x cubed, that's 3x squared. 13 times 3 is 39x squared. And 10 times x, the derivative of x is just 1, so minus 10. And so you can see that we're getting the same result both ways. And in a lot of cases, especially with some functions, dealing with the product rule form is a lot easier.